Our last video covered a lot of the basics about how to create some of the most common charts in Altair. Today's video is going to expand and build on these lessons to really explore the different kinds of ways that we might layer more information onto these representations. While there are more elements that are available in the Jupyter notebooks associated with this lesson, today we're going to cover some of the basics of adding additional variables to our visualizations, adding tooltips and some basic interaction, and adding and faceting and piping together charts that show the data from multiple perspectives side by side. So if you have your notebook from last video, you are certainly welcome to build directly on there. Just make sure that if you have shut down your Jupyter server since the last time you worked on this activity, that you run that first cell where you are loading in your data and that you run the cell where you are importing Altair. So here we have our notebook from last time, and I'm particularly looking at the cell where we created our scatter plot, exploring correlations between health and happiness. Well, one logical connection building on this might be, are health and happiness more or less correlated around different regions of the globe? So to do that, we might choose to add an extra variable to our visualization. In this case, what we're going to do is we're going to add color to encode the region that each country represents. And we can do this in a pretty simple way. All we have to do is add a new visual variable called color and bind this to the aspect of our data that we want to show through color. So in this case, the attribute we care about is region. So if I take my scatter plot and I rerun this with color equal region, I can see the different colors in my scatter plot that group the different regions of the world. So I can see, for example, Western Europe tends to have fairly high life expectancy and fairly high happiness. But what we're seeing is that maybe we don't see those deep regional correlations that we expected to see in our data. One of the things that we will talk about as part of the next series of lectures where we're talking about mapping is the idea that color is actually a really powerful mechanism for representing data. While its specific precision may be somewhat limited, the colors that we choose to use in our visualization have a direct impact on the aesthetics and the affect of our visualization, and they can also change the kinds of conclusions that people are drawing with that visualization. The default categorical color scheme that we see in Altair is very closely related to the Tableau schemes. But we might choose to use an alternative representation. So for example, one common place to source color encodings in visualization is a tool called Color Brewer. We can use the Color Brewer codings or any number of other color schemes that are pre-built into Altair. There's a whole list of them in the documentation. But we can use these color schemes to specify different kinds of color bindings. In this case, what we're going to do is we're going to bind our visualization using the spectral color scheme from Color Brewer. Now, the way we're going to do this is we're going to, instead of binding to a specific string, we're going to bind to an alt.color. And this alt.color is going to allow us to specify a custom mapping between our data and the colors that we're using. The first argument in this alt.color function is the data attribute that you want to use. In this case, we're going to use region. And then we're going to specify a new scale. So we're going to say scale equals alt.scale. And then we're going to specify the color scheme we want to use. In this case, we're going to say scheme equals spectral. Now, if we run this, you'll see that we get the same visualization, but a little bit different color scheme for our various regions. Now, one of the challenges with this particular plot is that we don't actually have a good sense of which point represents which country. So we have this outlier here, this yellow point that has high health but low happiness. And then over here we have a series of data values where these represent countries that are outside of the cluster of other countries in their region. They have lower health and lower happiness than a lot of the other countries in a similar part of the world. So we might want to investigate what countries are these specifically, such that we can use our prior knowledge of the world to try to develop hypotheses about what these outliers might indicate. Now, the way that we can do this is through what's called a tooltip. So a tooltip is the little text box that pops up when you hover over a mark. And we can specify tooltips fairly easily in Altair. So here I'm going to say tooltip equals, and then we're going to pass it a list of attributes that we want the specific values for. So in this case, I want to know what the country is and what its happiness score is. Now, if I run this representation and I mouse over the points in my scatter plot, I can start to see what countries appear where. So for example, in our two regional outliers here, I can see that Yemen and Haiti have lower happiness and lower health expectancy than other countries in a similar place around the world. So once we've got this tooltip, we might start to investigate other kinds of hypotheses. One hypothesis we might want to look at is we have all of this variance that's introduced between predicting happiness and looking at health or life expectancy. So might other variables help us continue to predict this relationship between happiness score and demographic factors about a country? So what we might choose to do, for example, is we might choose to create what's called a bubble chart. A bubble chart uses both the scatter plot position and the size of a mark to encode 3 different dimensions of our data. In this case, we're going to say size equals generosity. So we're going to explore, does our generosity measure help explain some of the variance that we see in our data? And so what we would expect to see if generosity helps explain some of the variance we see in the correlation between health and happiness is that we get a spatial gradient, either on the x-axis or the y-axis, that correlates to a relationship between generosity and health or generosity and happiness. But if I run this cell, what I see is that there's no necessarily clear systematic pattern for how space and generosity, space and size in this case, correlate with one another. So what that tells me is that maybe generosity isn't a very good predictor of the happiness of a particular country. Now, one thing to keep in mind here is that looking at spatial correlations of size is something that humans aren't necessarily as good at as they are with a traditional scatter plot where we're looking at correlations of position. So one thing that we can do is we can facet this data. We can start to pipe 2 charts together to look at multiple attributes and multiple relationships side by side. So what I'm going to do here is I'm going to create a visualization that allows me to look at the relationship between health and happiness right next to the relationship between generosity and happiness, to look at these correlations a little more precisely. So the way that we're going to do this is through an operation called piping. In order to pipe multiple charts together, what I need to do is I need to store each chart and its own individual variable. So for example, in this case, what I'm going to do is I'm going to create first a chart that is my health plot. I'm going to say health plot equals alt.chart. And for the sake of simplicity, I'm going to get rid of generosity map to size because we're just going to worry about spatial correlation here. Now, the next thing that I can do is I can create a second visualization. I'm going to call this generosity plot. And I am going to, for the sake of expedience, copy down the same code I had for my health chart, but I'm just going to replace this X binding with the attribute of generosity. So now I've created 2 variables that each hold their own visualization. What I'm going to do from here is I'm going to pipe these 2 charts together. And the way I do this is very simple. I'm going to say health plot pipe generosity plot. Now if I run my cell, what I see is that I get my 2 scatter plots. On the left, my health plot. On the right, my generosity plot. And I can look at the different relationships between these variables. In particular, are they well correlated with happiness score? Are they a good predictor of happiness? Based on the bubble chart we saw before, we would expect that health is a good predictor of happiness and is well correlated. And in fact, we see that on the chart on the left. and generosity is not well correlated. And in fact, we see that in the chart on the right, where there's no real discernible structure between our happiness score and our generosity. It's just kind of a blob of points. But by layering these charts together, we can look at these relationships side by side and do this comparison in a little bit different way than what we saw with the bubble chart, where we're layering all the information into one chart. So these all represent trade-offs in how we choose to look at these different patterns. That's all I want to cover for today's lecture. There are specialized functions that we can use to further facet our data and create interesting and non-standard types of visualizations, like scatterplot matrices or parallel coordinates plots. And the Jupyter notebook that accompanies this particular lecture has examples of these kinds of plots in them. I would encourage you to walk through those and post any questions that you might have to the discussion forum. With that, this is going to wrap our walkthroughs on using Altair. We will come back to Altair during future lessons to explore specific implementations, for example, specific ways we might implement different forms of interaction. And this is going to be the library that we use to primarily guide our hands-on activities in this course. Our next lessons will start to jump into the basics of mapping and thinking about how do we effectively create a mapping or a representation that takes us from data to visual elements in a way that shows the kinds of patterns that we want to show and shows them as faithfully and honestly as possible. I look forward to working with you all as we move on to this new topic.